Okay, so now let's look at the review the topics about the summation notation or the sigma notation. We use this symbol. This is the uppercase Greek letter sigma. This is called sigma I from equals 1 to n of a sub I. We use this symbol to denote a sum of several terms, n terms, which is a sub 1, when I equals 1, so ai becomes a sub 1, plus when I equals 2, a sub I becomes a sub 2, then continue, I equals 3, and the last term is I equals n, right? N. So here is a sub n. So this is the sum of n terms. Okay, we use this symbol to denote this sum. Here, ai is called the general term, the i's general term, the i's term. Okay, and I is called the index. And here 1, I equals 1, 1 here is called the lower bound. Lower bound. And here n is called the upper bound. So 1 and n could be changed. Okay. So now let's look at one example. So if we want to take the sum of I from 1 to k, okay, for example, of I. So what does this mean? This means the i's term is I. So the first term, I equals 1. So here is 1 plus I equals 2, which is 2, plus I equals 3. So this would be 3, right? Plus, and so on. The last term, I equals k. So here is k. So you see the relation between each term is the summation. Okay, so another example is if we have I from 1 to n of f of x sub I times delta x. Okay, so what does this mean? This means this is the sum of the terms. The term is called f of xi times delta x. So when I from 1 to n, so you have n terms, right? So the first term, I equals 1, so this would be f of x sub 1 times delta x, right? Plus I equals 2, so this is the f of x sub 2 times delta x. I continue, the last term, I equals n, right here. So this is the f of xn times delta x. Okay, so now let's look at some properties for this sigma notation or the summation notation. Properties. The first property is if the sigma I is from 1 to n of k times a sub I. So what it's equal to, this is k is a constant. So you can always take the k out, right? Then multiply by the summation. of k of a sub I. Okay, so now let's look at the left side. What does this mean? Okay, the left side is actually k times a1 plus I equals 2, which is k times a sub 2. Then plus I equals n, k times a sub n, right? This is the left side. The right side, it means this is the k times the parentheses. Okay, we use the parentheses to denote the sum. So this would be I equals 1, so it's a1 plus a2 plus I equals n, which is a sub n. Okay, so you can see these two are the same, right? This one and this one are the same. We just factor out this k from the left side. Okay, this is a common factor you can take out. So now let's look at the second property, which is the summation I from 1 to n of a sub I plus or minus b sub I. Okay, it's equal to the summation I from 1 to n of a sub I plus or minus the summation I equals 1 to n of b sub I. Okay, so you can expand like we did here to see both sides are exactly the same. So now let's look at some special summations. Okay, let's look at some formulas may be useful in the future. The first formula is the sum I from 1 to n of a constant c. So that means it's a c plus c plus c plus c plus c. So I equals 1, it's equal to c. I equals 2, it's still equal to c, right? So we have n c's, n times. So it's equal to n times c. The second formula, which is I equals 1 to n of I. What's that? This is the 1. I equals 1, it's 1. I equals 2, it's 2. I equals 3, it's 3. Plus I equals n is n. So 1 plus 2 plus 3 until n. So it's equal to n times n plus 1 over 2. The third formula is the summation I from 1 to n of I squared. So this would be 1 square plus I equals 2, which is 2 square, plus 3 square, plus I equals n, which is n squared. So this one is equal to n times n plus 1 times 2n plus 1 over 6. The fourth formula is summation I from 1 to n of I cubed. So this is the 1 cube plus 2 cube plus 3 cube plus the last one is n cube. Alright, the formula is n squared times 1 plus n squared over 4. This is actually the summation I from 1 to n I of I squared, right? Okay.